Hi, it's Dr. Phoenix. Today we're going to be talking about significant figures. How many times have you worked a problem like this and got an answer like this and wondered, how many decimal places should my answer be in? I've had students ask me this question 1,000 times. Well, there is a way that you can determine how many decimal places your answer should be. And what we're going to be looking at today is what are the numbers that are significant. How do we determine that? Part of that is determined by the precision of your instruments. For instance, if you're measuring a fluid in graduated cylinders, this graduated cylinder, you can see this is the mark for 3 milliliters and this is the mark for 4, and in between there are 5 slash lines. So each of these slash lines would represent 0.2 milliliters. This graduated cylinder, this line would represent 50, this is 60, and there are 10 slash marks in between, so each of these would represent 1 milliliter. Well, 1 milliliter, 0.2 milliliters. This graduated cylinder is more precise. If we were to measure this fish using a centimeter ruler, we could see that this fish is 2 centimeters, but not 3. We would have to estimate this last digit. So we could estimate approximately 2.5 centimeters would be the length of this fish. If we had a ruler that was in millimeters, however, we could see that this fish is 2 centimeters, 0.1, 0.2, 0.3, 0.4, 0.5, maybe 2.55 centimeters. So you can see we can estimate a little bit with a little bit more precision with a millimeter ruler versus a centimeter ruler. So the numbers that we can use in our calculations are going to be based on the precision of our instruments in part. Okay, so we see that the more decimal places that an instrument measures to, the more precise it is. What's the difference between precision and accuracy? Sometimes we throw those terms out interchangeably, and they're not. If we look at these targets, and let's use a triple beam balance as an example. Suppose we have a weight that we know the weight of it is 100 grams. And we put it on the triple beam balance and it weighs it as 100 grams. Okay, that scale is measuring the weight accurately. In other words, we're getting the true value. Accuracy refers to the truth. Okay, the true value of that weight would be 100 grams. And so we would be hitting the bullseye. We would be hitting it accurately. That scale is accurate. Now let's say we have another scale and we put the same weight on the scale, but this time we get 100.3 as our measurement value. We're going to go ahead and measure it again and again and again. And let's say after 10 times of measuring that, we get 100.3 each time. Well, as far as repeatability, we're getting the same results. This piece of instrument is, or this instrument is precise. It's precise. It's giving us the same values repeatably. It's not accurate. It's not 100 grams, but it is precise. So this piece of equipment would need to be calibrated. We would need to reset this equipment so that it is measuring that weight to the true value, so that it is not only precise but that it's also accurate. All right, so as we're looking at this chart, as we go up, we're becoming more precise. As the bullets get closer together, they become more precise. And as we go to the right, we're becoming more accurate. The closer we get to the true value, the bullseye, the more accurate we are. Okay, now what digits in a number are significant? Is there a way to determine that? Well, there happens to be a simple method of determining what digits are significant, and that's called the Atlantic-Pacific rule. And it goes like this. If the decimal is absent, A, start on the Atlantic side, A, and start counting with the first non-zero. So let's take this number. There's no decimal point. It's absent. We're going to start counting on the Atlantic side with the first non-zero. So this number does not count. 1, 2, 3. This number has 3 significant figures. If the decimal is present, then we're going to start on the Pacific side, present Pacific, and again we're going to start counting with the first non-zero. That doesn't count, but then we're going to count every number after that. 1, 2, 3, 4. This number would have 4 significant figures. So now that we know how to count significant figures, how do we know how many significant figures there needs to be in our answer in this problem? There are some rules to determine that. First of all, if you're multiplying or dividing, the number of significant figures in your answer is going to be equal to the number with the least number of significant figures in the problem. So if we look at this problem, 26.4, this would be the Pacific rule because there is a decimal point present, so we'll start counting on this side. 1, 2, 3. There are 3 significant figures in this number. This would be the Atlantic rule because there is no decimal point, so we'll start counting from the Atlantic side with the first non-zero. 1, 2. There are 2 significant figures in this number. So our answer would need to have 2 significant figures. 3168 has 4 significant figures, so that number would need to be changed so that it would have 2 significant figures. So we need to round the 1 either up or down. In this case we'll round it up, and the correct answer would be 3,200, an answer with 2 significant figures. In this division problem, 19 divided by 3, this is what you would get in your calculator. Most of you probably up till now would just guess as to how many decimal places you would put in your answer. But with this rule, you would use the one with the least number of significant figures in your problem. 19 has 2 significant figures. 3 has 1 significant figure, so your answer should only have 1 significant figure. 6.33333 should be rounded to 6, and 6 would be your final answer in this case. Now in addition and subtraction, it's just a little bit different. You would just stack your numbers up and align your decimal places, and your answer would be based on the number that had the least number of decimal points in the problem. Well, 13 has 0 decimal points, 1.6 has 1 decimal point, so our answer would need to have 0 decimal points. So 14.6 would need to be changed. We'll round that to a number that has 0 decimal points, and so that would be 15, of course. That would be the correct answer, 15. All right, so how many significant figures would we have in our problem that we started with? This is the number that you would get from your calculator. This is a division problem, so we would our answer would be based on the number in the problem that had the least number of significant figures. 10.6 is the Pacific rule. 1, 2, 3 significant figures. 13.960 is still the Pacific rule. We'll start on this side. 1, 2, 3, 4, 5 significant figures. So the least number of significant figures is 3. Our answer should have 3 significant figures. So we're going to round this number to 3 significant figures, and the correct answer should be 0.759. Okay, we'll do some practice of significant figures in class. If you have any questions, please bring them, and You can also send me a question on My Big Campus, and I'll get back to you just as quick as I can. I hope that's helpful, and I hope you have a great day. Thank you very much.